everyone. My name is Ashnita Bali, and I'm joining you today from Reading, UK. I'm super excited to be joining you on International Women's Day and to be part of Techno Day Online. And my topic today is preloading or prefetching modules for fast navigation. To start off with, let me just say that good user experience is key to an application success. When we visit a site, it doesn't feel great if we have to wait for the content to load. It actually feels really stressful, especially if we are on the run, like out and about, or if we're in a rush. And we're not alone in feeling this way. Studies show that users value the quick page application load time the most, more than how good a site looks or how responsive it is. The thing that is top on people's list is how fast an application loads. So today we're going to talk about performance techniques like code splitting and lazy loading that can help us make our application load faster. And then we're going to talk about a technique called prefetching, which we can use to make our application navigation to the other pages load fast as well. Because as we know, that the initial load speed is not everything that matters. We need the same good experience on all the different pages in our application. Before we talk about code splitting, lazy loading, and prefetching, it is quite important that we understand what loading an application involves. The browser does quite a lot behind the scenes to actually fetch the application from the server and to render the pages on screen. So I think that it is quite worthwhile to have a little tour behind and a look behind the scenes to see what the browser actually does to load our application. So here we go. Imagine that you are going to visit your favorite site. So you enter the URL in the browser's address bar. The browser has to first do a DNS lookup, so a domain name system lookup, to get the IP address for the server that hosts the application. It then does a three-way handshake with the server to form a TCP connection and a transport layer security negotiation to make sure that the connection is actually secure. It can then do a HTTP GET request for the website, and then it has to wait for the server to respond with the HTML document. Depending on the size of the document, so if the document is quite large, it might come back in more than one packet, as the browser uses a slow to start algorithm to control the network contention. So okay, so once so the amount of time that the browser might have to wait may depend on factors like the network bandwidth, the network latency, and it is important to highlight here that the browser cannot do anything like parsing the HTML document or downloading the resources like HTML, the JavaScript, CSS, or running the JavaScript or start to render the application until it has got this HTML file. So, right, the rendering is done on the main thread of the browser. So the browser's main thread is also responsible for running the application's JavaScript and for the user input. So the user input here refers to things like scrolling or clicks, etc. So the main thread does the rendering JavaScript, runs the JavaScript and user input. So it's important to keep in mind that while it's doing one thing, it's busy doing, for example, JavaScript, it won't be able to respond to the user input and or update the page, the display. Okay, so now say that once the browser has got the HTML back from the server, it starts to parse the HTML and create the document object model. And in parallel, there is a load scanner that starts downloading the priority resources like CSS, JavaScript, and the web fonts, while the while the main thread is parsing the HTML. And also at this point, it's important to note that a large part of the web applications tend to be made up of the JavaScript and images, but JavaScript takes longer to process compared to the images in the web applications, because the JavaScript runtime, besides downloading the JavaScript, it has to also parse, compile, and execute the JavaScript. So we can imagine that if the larger the file is, the larger the JavaScript file is, the longer it takes to download over a slow network especially, and the longer it takes to process the JavaScript and to execute it on especially on lower end devices with CPU, which is a lower CPU strength. So another thing to note about JavaScript is that by default it is a parser blocking resource, which means that when the browser goes through the HTML document and comes across the script tag, it will stop the parsing, the HTML parsing, to download while the JavaScript has been downloaded, parsed, compiled, and executed. So it is quite important to let the browser know through using the defer attribute on this script tag to not stop or not halt the HTML parsing and to download, parse, and compile the JavaScript file in parallel to while the HTML is in parsed. So that the browser can go ahead and carry on with the rendering process while JavaScript's been downloaded. So for example, if we don't use defer, it will halt the HTML parsing. Okay, so a critical rendering path refers to the sequence of steps that the browser takes, the main thread takes, to actually convert the HTML, CSS, and the JavaScript into the page that we can see on the screen, so displayed on the screen. So when when the browser receives the HTML document, it parses it and starts creating the DOM, which has got the content of the HTML. It's got the structure that is defined in the HTML. It parses the CSS and creates the CSS object model, which has got the calculated styles. And then it combines the DOM and the CSS object model into a render tree. So the render tree has got the visible elements from the DOM with the calculated styles. And then in the layout stage, the browser also has to determine the size of the elements in relation to the viewport size and the position on the screen. And then finally, you can do the paint, which is when the browser can, put the nodes on screen. So as part of paint, if there are elements like that are expected to change quite a lot, like the video, for example, and also elements with the CSS properties like 3D transform or opacity or will change. Indicates to the browser that these elements are expected to change quite a bit. They might be promoted into different layers. So in the compositing layer, it is being composed together. So once the paint is done and the compositing is done, we can finally see the content of our web application being displayed on the screen. And so we can say that the load speed refers here to the time from when we request our favorite website to when we actually see something rendered on the screen and displayed on the screen. Okay, so it helps to study this critical rendering path in order to see some of the improvements that we can already make in our web application to improve, to make the application render faster, really. So we can see that the render tree depends on the CSS styles. So by making sure, by prioritizing the CSS that's needed for the application to render, called the critical CSS, we can make this process faster. Also, by deferring the running the JavaScript, we can make this process faster. But at this point, we don't want to be guessing about how to measure the load speed either. But we don't have to worry, because Google Web Vitals gives us really user-centric metrics that break down the load performance of a web page, and also give us the times of what to aim for. So the first contentful paint refers to when the first content, like text or image, is being displayed on the screen. Largest contentful paint refers to when the main content is being displayed on screen. And as you can see, the time we aiming for is really quite short. So we want the first content to appear within a second, and the largest content to appear within 2.5 seconds. And as well as displaying the content on the page, it is really important that our page becomes interactive. The users can start interacting with our page really quickly. So metrics like first input delay, time to interactive, and total blocking time measures how quickly the pages become interactive and how smoothly it interacts, responds to interactions. And finally, we have cumulative layout shift as one of the user-centric metrics, which is about the stability of the layout. So sometimes when we are reading something on a website, and then we find ourselves the content actually just shifting because maybe a banner got loaded or an image got loaded, and we end up losing the space on our page where we were reading. So that's what a cumulative layout shift refers to. So yeah, we can really make use of Web Vitals and use Lighthouse and Chrome developer tools to keep an eye on these metrics, so we know how to measure and what to improve. So then, back to our ambition about improving the load speed. What can we do to improve the load speed of our application? We have touched on prioritizing loading the critical CSS, deferring the JavaScript to run after the HTML has been parsed, and we can also reduce the size of the bundles which is a topic which involves things like tree shaking, compressing, etc. But is not part of our talk today. So we will focus on the fourth point, which is delay loading non-critical resources. So how can we delay loading the non-critical resources? We can use a really great performance technique called code splitting. So instead of sending all the application's code to the user when they first visit our site, we basically split the application into smaller bundles and only include what is really necessary to render the application's main page. And that's all we ship with our application when the user requests to visit our site. So when we build modern applications, especially large applications, we use a JavaScript framework like Angular, and also we use a modular bundler like Webpack. And we end up having a in our application, in our index HTML, we end up having JavaScript for the runtime for Angular, for example, the polyfills to take care of older browsers, and then a main.js or main application file, which has got the code for the application. And if we have one big file with all the code in that one file for the application, including the various features that the user won't even see on the main page that are on other pages, then the application bundle is quite large. But using code splitting, which is a technique made possible with, using bundlers like Webpack, we can make sure that the main JS, the main application bundle, only has the code for the main page. And modern front-end web development uses modular architecture. Like so we may break our application into modules, into components which have got, so the standalone components which have got their own HTML, CSS, and JavaScript, and then we compose these components into to create features and to build the application. So this sort of modular architecture really lends itself well to code splitting. So each of the so we could split the application either by the code component granularity or by feature granularity, depending on what it suits your application. Together with code splitting, lazy loading goes hand in hand. So lazy loading is a technique where we only load a resource when it is needed. So here we're talking about lazy loading the JavaScript bundles. So on the application load, we basically procrastinate loading all the feature bundles until they're needed. So it's this really nice, happy feeling we sometimes have where we don't have to deal with doing a task just yet. We can put it off for later. So as I mentioned earlier, we use a Webpack for our bundling, and Webpack uses dynamic import for lazy loading. So dynamic import is a ES6 sort of function-like parallel of the import, the static import statement, which basically lets us import bundles, import modules based on some logic in the program, or based on an event. So if, for example, we have links on our page, and only when the link is to visit features, then when the user clicks on a link, then the dynamic import will load the bundle for that feature. It will parse it and compile it. It just won't execute just yet. I mean, no, it will. Yeah, and then it'll return a promise. So when the promise is resolved, then we have access to that module, and we're able to use the exported members from that module. So there is a problem with lazy loading. When we visit the site, now we have got our main bundle and the page rendered, and it's all good, the user's happy. But now they would want to, once the user wants to visit other pages, other features on our application, then the browser has to go through the same process again of downloading the bundle, and then downloading it, parsing it, compiling it, executing the JavaScript, and then rendering the page. So the user will have to wait. And it's all quite fast and fine on fast networks and on high-end devices, but on a slow network connection and for users on lower-end devices, the wait can seem quite significant and quite stressful. So we don't want to keep our users waiting every time they visit a new feature for the first time. So what can we do to improve the navigation speed? We can now use a technique called preloading. So basically, preloading is when you, instead of waiting for when the user has actually requested to visit the page, a feature page, while the user is already browsing on the home page, the browser will start preloading the bundles for the other features on the application in the background. It would download it, parse it, and compile it, just won't execute it yet. So at this point, I wanted to clarify the terminologies used for preloading and also the techniques used. So in the title of my talk, I have sort of gone and said preloading / prefetching. So there are two slightly different things, or used in a different context. So I think it is important to clarify the difference between preloading and prefetching. So let me just start off with the first technique for preloading, which is using the dynamic import that we already talked about. Dynamic import when we lazy load an application. When we lazy load a bundle, the Webpack uses dynamic import. So basically, using dynamic import to preload is similar to lazy loading, but instead of waiting till the user has actually clicked on a link to visit a page to download the bundle for that page, we do it while the user is already browsing on the home page, and then and in the background call dynamic import to start preloading, to preload the bundle. So that compared to what there are standards provided by the browser, which is link, rel, the prefetch and preload. And these are features built into the browser. And prefetch is quite similar in what it's trying to achieve to dynamic import, using dynamic import to preload the bundles. So prefetch is a hint to the browser saying that these are the resources that are quite likely to be used in the next navigation. So the browser, when it is idle, it can start fetching. It can fetch the resources for that have got the prefetch hint on them. As compared to the browser feature called preload, which is actually to tell the browser to load the resources that would probably be discovered a bit late in the current navigation. So it's a way to tell the browser that perhaps certain CSS or some resource that's hidden in JavaScript needs to be loaded sooner, so that they get discovered sooner than if the browser would parse and find it themselves. So I would I would really recommend checking out the prefetch browser feature for using as the technique for prefetching in the way that we want to use here to fetch the resources for the next navigations ahead of time. So I would also mention that Angular, which is what I use for my web development, uses the dynamic import. And so in my code examples that we will see later on, we will use dynamic import. Okay, so that leads us with the question about what do we preload? What modules do we preload? Do we preload all of the modules or not? If we have a small application with only a few small module bundles, it's completely fine to go ahead and preload all of the modules. But if we have a large application with lots of bundles, or if our modules are quite large, then we don't really want to preload everything, because we end up in the similar sort of situation, in a similar place where we started off, where if we shipping all of our application code to the user in the first load, but just slightly delayed till after the application has been rendered. So we don't want to send all of the modules to the user as it will give a bad performance on, especially on slower networks and lower end devices. The users are quite likely not going to use every feature on our application either. So they will be loading pages, modules that they don't need, and it will cost users with the data save mode. It will unnecessarily cost them to for things for modules that they didn't really need. So what we need instead is some sort of preloading strategies. We need a way to figure out what the users are likely to visit next, basically. And there can be many different strategies for deciding what to preload. And I would just go over some that I have come across or have heard of. So first of all, we could handpick some of the modules. Maybe we know which features are very popular in our application, or based on perhaps analytics. So we could implement code to indicate to the router which to indicate to the bundler, like Webpack, which modules to preload. We could use user behavior, like when a user hovers on a link to a page, to mean that they intend to go visit that page. So when they hover over a link, we could preload the module then. But sometimes we find that, if there are lots of links, we just, by moving around on the screen, we may be hovering over links that, you don't really intend to visit. So we could also decide to use mouse down as a more stronger intent that the user will visit, is going to visit that application, and then preload the bundles, because there is still a little bit of save between when the mouse down and the click up, and while the browser can already start preloading. We can make use of network information to find out what sort of network connection the user has, and decide not to preload if the user is on a slow connection, or if the user has got the save data mode turned on. So for that, we can use the network information API, which is web APIs available through the navigator connection property. So the connection gives us properties like effective type, which is essentially the effective type of your network connection. So you may be on using a desktop and connected to the internet, but the effective type will be able to say what this is the parallel of in terms of 2G, 3G, or 4G, and then we can decide not to preload things if in fact the connection type is slower. We also have access to the save data property, which lets us know if the user has got the reduced data usage mode turned on. Okay, so if you don't really want to implement code yourself for preloading strategies, I would be quite happy to recommend a couple of great libraries which have got prefetch bundle strategies that we can just use. So first of all, there is Quick Link, which is a library written by Adi Osmani, and it is quite small, I think smaller than 1 kilobyte minimize, and it basically uses the links that are visible on the user's viewport to then preload the bundles for those. And the way it does that is use some really helpful web APIs. And again, we can make use of these when, if we want to implement our own strategies, we can make use of these web APIs. So intersection observer API is used to detect when the links are visible in the viewport. And we've seen the navigator connection, the network information API, and request idle callback lets you schedule things to run when the browser is idle. So the quick link basically checks to see what links are visible in the viewport, and if the user is not on a slow connection and does not have a save data mode turned on, then when the browser is idle, preloads the visible bundles for the visible links. Okay, so the next library I wanted to mention is Guest.js, which is written by Minko Gerchev, I think in collaboration with Eddie Osmani. And Guest.js is based on analytics. So it uses analytics data like Google Analytics to decide what the probability is for our user to visit another page from any given page. So, for example, if we have a link to an about page on our application, and also a link to a context page, and the about page has 95% probability that the user visits the about page from the home page, whereas there is only 5% probability that the user goes from the home page to the context page, then Guest.js will preload the about page in the background for us. So yeah, if we don't want to if we want to just take the guesswork away, we can use Guest.js to do the work for us based on analytics. Right, so now we've come to pretty much concluding our talk about providing the user a good experience through improving the application's page load performance and the navigation speed to the other features in the application. So basically, we have, throughout these techniques, and using these techniques, we are able to build web applications which are really mindful of slow network connections, and they're mindful of users with lower end devices with slower CPUs, and also mindful of users with the save data mode on. So yeah, so now all we've got to do left to do is have a little look at the demo and try and see in code what we've been talking about preloading, and look at some preloading strategies for in action. Okay. All right, so first of all, I want to show a strategy. So here I have an application. It's really quite simple so we can just focus on watching the network tab and see what gets loaded. So we've got on the home page links to a docs page and resources, and we've got some extra menu options available on the site as well. So this application at this moment has got the preloading strategy to preload the bundles when the user hovers on a link. So basically, the thing we want to do is keep an eye on the network tab. And so now when I go and hover, oopsie, let me take that. Okay, now let me just start that again. All right, so sorry about that. Now when I go hover on the docs link, then you'd see on the bottom side of at the bottom of the network tab that we've got the docs module JS been loaded. And now if I go and hover on resources, then the browser has gone ahead and preloaded the resources module. And if you notice that I haven't actually gone to visit any of these, so these are preloaded while I am still browsing on the home page, really. So I may go and actually visit the resources page now, and you see the resources module is already loaded, so it's able to just quickly render that page. And then if I hover on the community, this button, which leads to a page with the resources about the community, then it's preloaded the module for the community page as well. Okay, so that's one technique, strategy that we talked about, that we download things when the user hovers on something. So now I want to go ahead and look at the code. And so I use Angular to implement this application. And in Angular, we have got the Angular router that takes care of the preloading for us. So all I have to do really is specify a preloading strategy, which has been implemented in a service. And I register that service with the router. So I've got here router module, and for root is the service for the whole application. And I've provided the routes, which simply is the home, docs, resources, etc., what we saw in the demo just now. And then I have passed in a option, which has got the preloading strategy. So now I'll go ahead and change the preloading strategy from hover to using the quick link, which is the library written by Eddie Osmani that we talked about before. I should mention that Minko Gerchev has actually written the Angular, the package for the quick link package for Angular. So all we have to do is install ngx quick link, and then we add it into, we basically create a shared module, and we import the quick link module and export it. And so the features can then we can share the quick link module between the features as well, and they have it available. So let me go back to the routing and module. So all I have to do when using the quick link strategy is to install it and just use the module. And let's see that in demo. So I saved that, and now my application will use the new strategy, which is the quick link. And let me just clear the network things. And then, so I would just like to go ahead and just hide the links from the viewport. So now when I go and scroll and these become available, let me just, okay, so it is working. So, okay, once, what I wanted to show, I didn't execute it well. So hopefully you saw anyway that once the extra options became visible, so feature A, feature B, and feature C became available, visible on screen, then in the network tab, we could see that Okay, we can see that. I hope I've done it correctly. I think, let me just, okay, let me just try this again to make sure that we are in fact using the quick link strategy. So, all right, so I'll do a refresh, and we've got the all the runtime, the polyfill main.js bundles being fetched, which is done through the HTML document, and then through preloading, through the quick link strategy, I think, the docs and resource modules have been preloaded as well. So now when I go and click on resources, which has made available, like made visible on the screen, this the community link to the community page, and then we see that in the network tab, the community module has been preloaded as well. So now I'm gonna click on these extra menu options, which will make the features A, B, and C visible on screen. And then the network, the browser should go and preload those modules as well. So here we go. And right, so now the features A and B have been preloaded. I think, well, I was expecting feature C to be preloaded as well, but I think I know what I've done. I haven't shared, yeah, I think I haven't included the shared module in feature C. So anyway, this does give a demo of the quick link strategy, which preloads the modules for the links that are visible on in the viewport. It preloads them. Okay, so let's go back to now have a quick look at one of the code. So let me show you how we might do a handpicked, how we might implement the strategy to just decide which bundles to preload ourselves. So basically, we create a service, and which will implement the preloading strategy. So this is very Angular specific, and Angular makes it quite easy for us to create a preloading strategy so it gives us interface called preloading, and all we have to do is implement it. And so we would have a method called preload, which will get the route information from route config, and we will return an observable, which basically lets the router know if this is a route that we want to, if this lazy loaded route is one that we in fact want to preload. So I can use the network information API to check. So here I've got navigator.connection, and then I've made an array of networks which I consider to be slow. It's up to you. 3G might not be slow. I don't know for you. So then in this in the preload method, all I am doing basically is saying if the network is slow or the user has got the save data mode on, then return an observable of null, which will let the router know that don't preload this route, and otherwise it'll go ahead and check to see if it is a route that in fact I have selected to preload. And so I need to show you at this point where the route configuration, so which is in the routing module. So I will switch over to that and come back to this method in just a moment. So if we go over to the router configuration, is an array of all the route paths. And the routes are basically objects with a path and the component to display that will render that path. So that's the URL, and that's the component that will be rendering that URL. And in Angular, we use the load children property, which is then using the dynamic import that we talked about, and which is a promise. So once the promise is resolved, we have got the module, and we actually can use this module. So this is done by Webpack. Angular uses Webpack to do this dynamic loading for lazy loading. And so this is the route configuration that the preloading strategies have. And so once they, it will go through each of these and see which route has not been, lazy loaded route has, so lazy loaded being the ones with the load children property. So which of these lazy loaded routes has not been preloaded yet? And then we can use a data to sort of provide a little bit of extra information in this route configuration to say preload this one, preload. So this is us handpicking the routes to preload. So when we go back to our service, we are basically then able to use that information to say, check the configuration and see if it has the data property, and if that was set to true, then let the router know that yes, preload this the bundle for this route. And that is simply it. So that is all we need to do to implement a preloading strategy ourselves, rather than using a library. So yeah, so to basically sum up, I would just recap that there are quite a few strategies we could use. So you can think about what suits your application. We can be mindful of the network connections and uses data save mode on. We can use libraries like QuickLink to make it easier for us if we don't want to implement the strategies ourselves. And then we get just out of the box things like doing the preloading when the browser is idle. Or we could use that in our code ourselves to use the request idle callback and do the preloading only then. And yeah, simply that is basically all I have, and that's the end of my presentation. Hopefully you were able to get some useful information away and feel excited to go and try code splitting, lazy loading, and prefetching or preloading if you haven't already. If you aren't already familiar with it, and if you already are, then perhaps you feel excited about looking into the various strategies that are available. And so with that, thank you very much, and a really happy International Women's Day to everybody. Thank you. Bye-bye.